So yesterday we talked about the basics of statistics, and that is what we are going to put more focus on today. So if you guys recall, statistics is nothing but those Sandrine, Heslin. What happened, Arav? So my request to you all would be, make sure that when we are in the class, nobody is busy texting, nobody is busy flashing emojis. Those are unnecessary distractions in the class. We don't need them. Okay? And not only for Arav, I mean for all of us. Even if you see me playing with emojis, let me know. Okay? So, Sanvi, it takes me 1 or 2 classes to memorize the name. That's why I'm calling out your name so that I memorize your name better. Okay? Okay. So, if you don't see Aryahi coming in another 2-3 minutes, we'll probably close the door so that you guys get the AC. So, we start talking about statistics. And concept-wise, statistics is a method. It's a technique, it's a platform, it's a subject that helps us collect data, organize data, massage data, to prepare some interesting reports. By looking at those reports, people can make some decisions. That's about statistics. Like we were saying, okay, doctor says, okay, you have not been keeping well, do one thing, record your temperature every day in the morning and the evening and send me the data for next 1 week. So what the doctor is trying to do is trying to record your temperature and see how your temperature is fluctuating for the next 7 days. Based on that, he or she can make a judgment that, okay, is that treatment needed or this is natural? Okay. So first step was collecting data, collecting your temperature, 7 days, 14 temperatures, and then collected it, organized, okay, Monday this much, Tuesday this much, Wednesday this much, you organized it, and then you put that in a table form or in an email or in a text message, whatever. That is like you reported that to the doctor. Now doctor looks at the data report and makes a decision. Okay, 2 antibiotics or 20 antibiotics or no antibiotics, depending on how your temperature was fluctuating for those 7 days. Yeah? Alright? So that is the purpose of statistics. Now, you will always have unorganized or organized data. When you have unorganized data, you will organize them. Let's say I have, let's say I took a test. Okay, by the way, just a news for you all. We will do our test, which we had taken a break for some time. We'll do a test for everybody sometime in the mid of August. Okay? But good thing is, no results will be published. I don't publish results and say, okay, this child did wonderful, this child could have done better kind of thing. No. I take the test, go through the test answers, and based on that, I try to figure out for myself that, okay, did I do a good job as a teacher? What are the topics where my kids are struggling? So I will cover those topics again. So nobody gets 100%, 80%, 70% kind of a score from me. I get a score for myself to know what are the topics that I have done well, where kids are able to apply those concepts, versus what are those topics where my kids could have done better. So that's the purpose of the test. Okay. So a big relief. Nobody is going to worry about this thing. Only the teacher knows where he has to do a better job. Okay. So Maida, I need your help to close the writer better. Now, so that was on the test. Coming back to statistics. Can everybody hear me okay? Okay. Okay. Sandrine, Celine, Arihan, very quiet. Can everybody hear me okay?
Yes.
Okay.
Yes, sir.
Sharia is okay? Wonderful. Now, let's look at it. I said, then you have to open the door. So let's say I took a test of all the kids, okay, in level 2. Let's say there were 15 kids. Cover it quickly and close the door. One of the table is missing, you can pull a chair better. Or you can sit in the front row, any which way is okay. Mind, close the door very quickly, run and quick. So I took a test of 15 kids. I got, it was a 20 marks test, okay? So somebody got 15, somebody got 18, somebody got 19, somebody got 7, somebody got 17, somebody got 15, somebody got 12, 8,
Out of what, sir?
out of 20.
Okay.
18, 16, 11 and 19. So this is the score that kids got. There were 15 kids and this was a test for 20 marks. Okay, I probably gave a tough question or whatever. This is the score everybody got. I just recorded it. And I did not put even a name because I didn't want to disclose everybody's name. Okay, like my basic. So don't worry about looking at the numbers, but okay, Richita, I know you are trying to look at the numbers. This number is not looking very clear, but don't worry about it. What I'm saying is, I have certain. I took a test of 20 marks and I recorded the score by every child, and this is what I have. This is a candidate where I can say this is unstructured data. This is unstructured data. I cannot make any head or tail out of it. Okay? This is not clear, not easy to organize or play with it. This is unorganized or unstructured data. Now, like we were discussing yesterday, we said, okay, fine. Let's put that in a table. Score, number of kids. I said, okay, 0 to 10, 10 to 20, or 10 to 13, 14 to 17, let's say 11 to 13, 14 to 17, 18 to 20. Now, 0 to 10, 1, 2, 11 to 13, 1, 2, 3, 14 to 17, 1, 2, 3, 18 to 20, 1, 2, 3, 4, 5, 6. They are missing something, but don't worry about that. Okay, 18 to 27 actually. Yeah. So from this unorganized, this became an organized data. By looking at this data, you can make out that, okay, fine. Out of the test for 20 marks, this is how kids have scored. This many kids, I mean, when I look at this score, this is a matter of concern for me. There are probably 2 kids in the class who did not do well. Either I did a very bad job as a teacher or they did not study at all. This is what I will work on. These are the kids. See, look at out of 15, there are 7 kids who got more than 90%, 18 and above. That means I'm not doing that bad. Probably kids are doing fine and they are also working hard from their side. So this gives some inferences based on the data. Once you structure it, it gives you some inference. And you can plot it. You can plot it. So now, Advik, coming back to your point yesterday, what I'm doing is 0 to 10, 11 to 13, 14 to 17, 18 to 20. 0 to 10, 2 kids. It is 1, 2, 3, 4, 5, 6, 7. Eleven to 13, 3 kids. 14 to 17, 3 again. What is that? Hello, Suina. Suina was missing yesterday.
I went out.
What is that?
I went out.
Oh, okay, no worries. So now look at this thing. Whatever information we had, we plotted them like a contiguous thing. 0 to 10, 11 to 13, 14 to 17, 18 to 20. All these are continuous. This is called histogram. If I had plotted it like a bar chart, this is 0 to 10. 0 to 10 is 2. 1, 2, 3, 4, 5, 6, 7. 0 to 2, 10 to 13 is 3. 11 to 13. Then 14 to 17 is also 3. Eighteen to 20 is 7. This is called bar chart. This is called histogram. Same data represented in a different way. Here you have all bars where there is a relatable history to it. This is called histogram. When you are talking about contiguous thing, this is mostly useful when you are talking about related data when they add up to do something. Here you can treat them all separate, okay? I mean, let's say if you had a situation where there was nothing for 14 to 17. You don't need a bar there, 14 to 17. You are better off with a bar chart. If you have continuous data, then you use histogram, okay? Both look similar, both do similar job, but histogram is more continuous in nature. Here you need not have any continuity. It just says, okay, this is a reference point and what is the number of records that you have against that. So this is bar chart, this is histogram, and both are statistical tools that help us put the structured information in an organized way. Yes, Peter?
Can you use a pie chart to measure data as well?
Yeah, you can. So we'll come to pie chart also. Now let's go step by step and we'll come to that. We'll try relating it, okay? Because if we don't think about them, they look similar, okay? They look similar. Let's talk about a situation, okay? Let's talk about a situation where I have let me pick 2 names or 3 names, 2 from the screen, 1 from the class, okay? From the class, let's say Suhina and Sandrine, okay? So Suhina and Sandrine from the class, from the screen, and let's say Sanvi from the room, okay? Always my new students are always my first pick. So here Sanvi. Interestingly, everybody is starting with S. Now you guys know there's a reason, okay? Now let's say Suhina spent, let's say, $60 for a dress. All three of them had to buy some dress, 1 dress for an event. Suhina spent $60. Sandrine spent, let's say, $65, and Sanvi pick a very economical option, let's say $45. Okay, and again, I'm not trying to say who wants to spend more. I'm just giving some data. Okay. Now, if I have this information, if I have to plot it, I'll say, okay, this is Suhina, this is Sandrine, and this is Sanvi. Suhina spent, let's say 20, 40, 60, 80, 100. So Suhina spent $60. So this is Suhina's bar. Sandri spent 65. Oh, sorry, Sandri spent 65. So this is Sandri's bar. And then Sandri spent 45. This is, so let me color them different, okay? So, Sandri's bar is in red in color, and Suhina's, let it remain the same color for now. This one is green, okay? So now, here this information is a good information to look at. I mean, just by looking at this bar, okay, it was Sandri who spent the most dollar, okay? Most money for buying the dress. And who made a very smart move? Okay, Sandri made a very smart move, not spending a lot of money for that event. I mean, just an interpretation. Here, the information may or may not be related. Okay? May or may not be related. So, in case of bar chart, there is no compulsion that your data has to be related. Now, let's look at another situation where I am keeping the bar chart here. Okay? Now let's say I picked up 4 more kids and I said, okay, I will distribute $100 for you guys to make a smart purchase. So I said, okay, $100. I said, let's say I picked 4 kids, and this time I picked, let's say, Sami, then Aryahi, then Arab, then Arihan. Okay? I had to distribute this $100 among 4 of them. I said 30% to Sami, 20% to Aryahi, 25% to Arab, 30 plus 20, 50, 25, 75. Let me make it, I'm giving little more to Aryahi now. 30 plus 30, okay. Make it 35 and make it 32. 35, 32, 25. 35, 32 is 67 plus 25 is 92. So, Arihan, because sorry, I gave you only 8%. Okay? So, this is what I gave. If I want to plot it, putting in a bar chart is possible. I can do that. Hello, Tansi. Tansi was not there for a few days in this class. Tansi, can you hear me okay, beta? Your screen has frozen probably. That's why. Okay. So here, if I put this like a bar chart, Sami's bar will be 35% tall, 32% tall. We can do a relative comparison, but everything is adding up to 100%. Now if I put that like a pie chart, I'll say 35%. Let's say this is 35%. 32%. 25%. Let's say this is 35. 32. 25. I need to do better drawing, I think. This is 32, 35, 25 and 8%. This is called pie chart, where you are splitting the pie among people. Here, it represents the relative difference, okay? Which one is taller, which one is shorter, which one is more, which one is less. This represents the split, a distribution. That is why you use pie chart when something is adding up to 100%. Okay? Let's say if I have to represent how my height has increased for first 20 years of my age. Will I use a pie chart? Let's say when I was 5 years old, I was, let's say, 2 feet 3 inches tall. When I was 10 years old, I was, let's say, 4 feet 1 inch tall. When I was 15 years old, I was, let's say, 5 feet 5 feet tall. When I was 20 years old, I was 5 feet 6.5 inches tall. Will I use a pie chart for plotting this?
No, sir.
It's not adding up to anything, right? No, Sanvita. So Sanvita, you got little late. We are talking about statistics, okay? So we looked at what is a bar chart, what is a histogram, and right now we are looking at pie chart, and we are kind of thinking with ourselves or arguing with ourselves to understand what is the difference between a pie chart, a bar chart, or a histogram. One difference that we observed between a bar chart and a histogram is, in case of histogram, they are continuous, okay? Let's say, if I'm talking about my height change, 0 to 5 years, I grew to 2 feet 3 inches, let's say. 10 to 14 years, I grew to 4 feet 1 inch, 1 inches. 10 to 15 years, I grew to this height. So here, you are seeing things are continuous in nature. 0 to 5, 5 to 10, 10 to 15, 15 to 20. They are continuous. I can always put that as a bar chart or histogram. I'm trying to figure out, can I use a pie chart? Because pie chart is a sum of things, okay? If I say my age at 5, my height at 5 years, height at 10 years, 15 years, 20 years, if I try plotting in a pie chart, that will look messed up. It will not make any sense. Right? So, this is one of the difference. Pie, see, people say, okay, what is my piece of the pie? So, it's always a percentage. When you are dealing with a situation where you have to plot information which can be distributed among all the participants in a certain way, certain percentage way, that is when you use a pie chart. When you talk about disconnected data, you can use a bar chart. When you are talking about continuous data, that is when you will use a histogram. Does it make sense so far?
Sir?
Yep, yes I may.
Can you use a bar graph even if there is continuous data?
You can. So bar chart is the most generic form of a statistical tool for reporting, okay? So bar chart is the most flexible one. So it's like, sorry if I'm giving a wrong example. I'm just thinking, and trust me, I'm not trying to offend anybody. Let me not give that example. That will sound very stupid on my part. Let's not do that. Okay, let me not talk about that. That's not a good idea. So, let's say somebody who speaks 5 languages versus somebody can speak only 1 language. Okay? Somebody who can speak 5 languages is your bar chart, which you can use for all scenarios. Somebody who can speak only 1 language, there is a restriction or limitation. That applies for things like pie chart. Pie chart in simplest form, if you want to understand it, it's like you are distributing something. Let's say I'm talking about my budget for the month. Let's say I got this much salary, okay? I know this is very little, but still, let's say this was my salary. And don't be surprised, this used to be my salary in 2004. Those days, it used to be much less and I was less experienced. So, this was my salary. Now I have to plan, okay, some money will go for rent, some money for grocery, some money for utility bill, some money for trash, some money for gas, some money for insurance, and some extra money for medical and other stuff. And obviously for going out, watching movie, whatnot. Okay. So let's say out of $2,000 rent, I'm paying let's say $800. Grocery, let's say $200. Utility bill, I have $100. Trash, I have to pay $50. Gas, I have to spend almost like $100. Insurance, I have to spend $200. 8 plus 2,000, 1100, 1150, 1250 plus 1450, and then I'm keeping another $550 as a surplus extra money for emergency, for unknown expenses. So my total salary is distributed among these many things, and they will add up to this. I can use a pie chart. That will make more sense. And by looking at this, you can see, okay, maximum money of my salary is going for rent. Then little bit for grocery, little bit for utility, little bit for trash, little bit for gas, something more for this thing. So this is rent, this is medical emergency, and then this is trash and everything else. By looking at this pie chart, you can make out where majority of my money is going. So pie chart is used as a tool for financial planning very extensively. When you are distributing your resources among different modes of expense or different categories of expense. Okay, so pie chart is very extensively used for financial planning. You will see that being used very commonly by the CFOs of the world. They use it.
What was the medical bill?
Medical thing, I was saying that I am keeping some money for medical and unknown expenses. This is like a saving, where I don't know where I would end up spending money, but I am keeping some money in reserve so that it comes handy during a rainy day. Yep. So is everybody clear? Sanvita, Dikshita, Sandrine, Advik, Arab, sorry, everybody? See, everybody is quickly raising their hand because they don't want to get their name called out. Everybody okay so far? So we looked at what is a bar chart, what is a histogram, what is a pie chart. These are three things that we have talked about. Now, there is something called a line graph also. There is something called line graph. Dikshita, are you with me, beta? Yeah?
Yes, sir.
Okay. I see Dikshita is either stressing out to see what is on the board, or there is some other window which is getting her stressed out. So, okay, coming back to this one. So, there is something called line chart, line graph. Any idea what it could be?
Can I try?
Yes, please.
A line graph could be like, instead of bars, like on a bar graph, there would be a line instead.
Yeah. So the example that I was giving, how my height has changed over a period of time. When I was 5 years old, 2 feet some inches. When I was 10 years old, 4 feet, let's say 3 inches. When I was 15 years old, I was 5 feet 1 inches. When I was 20 years old, this is the best I could get to, and then I have to stop. Yeah. If I have to represent this, I can always represent this in a much cleaner, less clumsier way. I'll say 5, 10, 15, 20. This line represents my age, and this line represents my height. Oh, when 5 years old, 2 feet 1 inches, maybe here, somewhere here. 10 years old, 4 feet 3 inches. 10 years old, 1, 2, 3, 4, 5, 6. I could not get here. I have to stop here.
Kind of like a coordinate plane?
Something like a coordinate plane, yeah. So 10 years, 4 feet 3 inches. So 4 feet 3 inches, somewhere here. 15 years, 5 feet 1 inches. Okay, here. 20 years, 5 feet 6 inches. So 20 years, I could get up to here. Now you look at this. This represents how a growth has been. Imagine if when I was 20 years old, my height decreased to 3 feet. There's a medical problem. Yeah? There's a serious medical problem. It can happen only when there's a serious problem. So regardless whether there's a problem or not, the line graph shows your trajectory of how data is changing. Be it with respect to age, be it with respect to your salary increase, be it with respect to how population is increasing, be it anything. When you have to show the trend or trajectory of data, you use a line graph, which is nothing different from what you guys have seen in a coordinate plane. So this is line graph. You would probably see the line graph something like this, which is representing the tip of the bar. You can represent a bar chart, and the tip of the bar, actually, this shows the trend. Instead of this much of clumsy image, you only look at the trend. But okay, fine, I can make out that this is increasing. And I have the points where I can see the value also. So, you use line graph which represents the trend. Okay? Or how the two consecutive data charts are changing with time. Is it making sense or kind of confusing? Is everybody clear?
Yes.
So we talked about bar graph, histogram, pie chart and line graph. There are things like scatter plots and there are things like dot plots. Who remembers them? Or who has come across it? Let me wake up everybody if I am making you guys sleep. Okay? Let me start with Sammy.
So you want me to describe a dot plot?
Yeah, tell me what is a dot plot? I mean conceptually, what is a dot plot, what does it do, and when do we use it?
So like any graph, you have like a line at the bottom, obviously, with markers for how many numbers you have, so like 5, 10, 15, 20. And then you would have a few numbers like 2 15s, 5 13s, 3 17s, right? And then they'll all be in a random order, they won't be together,
Okay.
right? But then you will put a dot for how much each number is. Like for 15, you put 2 dots. For 13, you put 5 dots above 13.
Okay.
And then for 17, I forgot what number.
Okay.
Yeah.
You made a very good start. Let's see what Dikshita has to say. Yep. Describe what is a dot plot
Oh.
and when do we use it?
I know what scatter plots are.
Okay. We'll come to scatter plots also. We are just trying to go through dot plots, everybody's understanding, and then we'll come to scatter plots. Sorry. That's good. That's a good information for me. When you guys don't know something, that's an opportunity for me. Let's go to Shaurya. I'll come to you with that. Okay, Shaurya, tell me. What is your understanding of dot plots?
So a dot plot is kind of like a form of data, and it's technically like a series of numbers and how many times that number that thing was used, which is represented like dots that go above it, and it's mostly used to like make a form of data or like a group of something.
Okay. Let's see what Arav has to say. Yes, Arav.
Dot plots are like a number line. They go positive or negative. So there's like a bunch of numbers where you graph them, and then each bar represents each number. So the amount of dots that are in the number line, the amount of numbers will be added to.
Okay, let's see what Sharmini and Suleen want to say. Yep, go ahead, Beta.
A dot plot shows like a repetition of numbers in a series of clusters, asymmetrical or asymmetrical.
Okay. Sanvita, anything different you want to say? Yep.
It's like a plot that uses dots to represent the data, and it shows like the frequency or the distribution. This how like they're distributed.
Any idea? Okay, good. Any idea? What is a dot plot?
It's like a number line kind of thing, and then there's like dots that would signify like one school or like one result, and it's like a series of numbers at the bottom. It's kind of
Okay.
hard to describe, but like
Similar?
I have to
Okay. So, see, you guys made my job easy. What I did was I borrowed the concept from each one of you, and I'm just going to package it and say it back to you guys. Nothing from my side. If you guys told me something wrong, you will get it back from me. Now, dot plot, like most of you described, this is my compiled version of it. Dot plot is a statistical tool that helps us represent data and the frequency of a data. Okay? So, let's say I'm talking about how much time I'm taking to drive to work every day, and I'm trying to plot it for 30 days. Okay? I'm probably sometimes taking 1 hour, sometimes I'm taking 1 hour 15 minutes, sometimes I'm taking 1 hour 30 minutes, sometimes I'm taking 1 hour 45 minutes also, thanks to the interesting traffic of Dallas. Now, 30 days data. There were 8 days in a week, 8 days in a month, 3 plus 3 plus 6, 8 days in a month where I could reach office in 1 hour. There were 7 days in a month where I could reach in 1 hour 15 minutes. Six, 9, 12, 14. So 8, 7, 14. Here, what is happening is, this is called dot plot, where I'm defining the dots to represent the frequency of the occurrence of a certain event. Here, how many days I could reach office in 1 hour? 8. How many days I could reach office in 1 hour 15 minutes? 7. How many days I took 1 hour 30 minutes to reach office? 14. I'm blessed to reach office. How many days I took 1 hour 45 minutes also? Thanks to those awesome drivers who lead to accidents on the roads. One day I could see 3 accidents and I got stopped every 15 minutes. And it took me 1 hour 45 minutes. So here, when you look at this, like you guys were saying, this is like a number line where every dot represents the frequency of occurrence of that number, or that record, or that data scenario. So dot plots are nothing but a statistical tool which helps you plot the frequency of occurrence of a particular data. Okay? So whenever you are dealing with frequency, some number coming again and again, dot plot. When you are looking at data which is unrelated and there is no frequency, bar chart. When you are looking at data where something add up to the whole, pie chart. When you are looking at representing a trend, line graph. When you are looking at data which is continuous in nature, 0 to 10, 10 to 15, 15 to 20, histogram. These are the 5 tools that we talked about. Any questions? Saurya, Arav, Advik, Sanvita, Tansi, Vasundhara, Arihan. No question? Sandrine, Celine? No question? You guys are giving thumbs down to your teacher. Not good. Okay, alright. So, good. I wanted a thumbs down only this time because that will at least make me believe that we are following the right path. Then comes the next one. That is called scatter plot. Now, let me do the same thing, same dirty technique to learn the concept from you guys and then spit it out. Let's see who knows about scatter plot. Tell me what all you guys know about it. Okay, Arav, tell me.
So a scatter plot is what?
So you have to come a little closer to the mic and say it a little louder.
So scatter plot is when for example, it measures like a point, but it's not in a control order, like not in a line. It's scattered on.
Okay, let's see what Vasundhara says. Yes, beta. I'll come to you also. Yes, Vasundhara, tell me.
A scatter plot is like a type of graph that uses like dots that is scattered to show like a relationship between like two sets of numbers.
Okay. Arav, hands down. Let me go to Aryahi.
So it's kind of like a mix of a line graph and forgot the name, dot plot maybe.
Dot plot.
So
Okay.
it's scattered all across the graph and it kind of makes a relationship to show you like how two numbers relate.
Okay. Sanvita.
It uses like the x and y axis, and the position of each point is determined by the two variables put in for that point.
Okay. Sammy.
So it's kind of like a dot plot and a line graph mixed together, but you don't put them in line.
Okay. Dikshita.
In a graph where like the points are scattered and it shows the relationship between the variables and numbers.
Okay. Sorry. Anybody else? No? Okay. Scatter plots. Again, same dirty technique. I borrowed the concept from you guys. I'm going to give it back to you guys with some packaging, some polishing around it. So scattered plots, again, scatter plot. This comes from dot plot, and scatter means when things are scattered, all scattered. When you are dealing with large volume of data, and occurrence of event. Imagine on a road, on a freeway, in 30 minutes, how many cars went by? Maybe 10,000, maybe 20,000, maybe 50,000. Imagine a camera taking picture of the speed of each and every car, or recording the speed of every car and plotting it on here. Okay? 70, 60, 50, 40, 20, 30, 90, 80, 60. Here, this is speed, okay? 10, 20, 30, 40, 50, 60, 70, 80. And here it is, let's say, 9 to 9:30. 9:30 to 10. 10. 10:30 to 11. Okay, in the morning. See, there are some people from 11:30 to 12:30 are driving at a speed of 10 miles per hour on a freeway. And there are some people between 9 and 9:30 driving at 90 miles per hour on a freeway, which has a designated speed of 70. But what you see here is most of the people across all time zones are driving the range between 70 and 55, where the maximum data is recorded by the camera. This is where you see maximum density. Or even from 9:30 to 10, when they are peak office hour, most of the people are driving between 30 to 50. From this data that you see that so much of information are there. But you can draw an invisible line which says majority of data is concentrated around that. Do you guys remember what is the name of that line, that invisible line? Deekshita, do you remember?
Line graph?
No, not line graph. There is an invisible line. When you look at a scatter plot, there is a very invisible line that says, okay, this is my average trend. This is the line around which most of my data revolves. 60% of data is yes, Tansi.
Is it the line of best fit?
Line of best fit. Yes. So line that best fits with majority of data or defines the trend. These are outliers. Somebody driving at a speed of 10 and somebody driving at the speed of 95. These don't define the average trend. This line of best fit, which determines the overall behavior for majority of the data, that is called line of best fit. And that's an individual line, okay? You and I can argue or disagree. I will say, it looks like line of best fit is this one. You say, no. To me it is like this. This one. And I might say, no, you guys both are wrong. This is probably line of best fit. Fancy will say, see, I told you the definition of this. In my view, this is the line of best fit. RF says, I'll give you a AI view of the line of best fit. My AI is saying the line of best fit is here. What I mean by all those nonsensical example I gave was that line of best fit is the guesstimated one. There is no mathematical science. There is no mathematics or there is no science. I club them together, mathematical science. I don't know if there is a word like that or there is a subject like that. Mathematical science. Something I invented today. Anyway, but there is no math or science which tells you, okay, this is how you derive it. It's a guesstimated view which says, okay, this is probably your trend. This is probably the line of best fit is giving you the possible view around where majority of the data is lying, okay? Which gives a trend. And these are called outliers. So now the point is, when we talk about scatter plots, when do we use scatter plots? We use scatter plots when you are dealing with large volume of data. See how much scattered it is. Sami, is that okay, beta? Yep, okay. Ariyahi, Myra, phone? No phone, right? Okay. So here, when you look at scatter plot is used mostly in a scenario when you're looking at large volume of data and trying to make a guesstimated view of what is the trend that you can derive from this, which will help you determine a possible extrapolated behavior out of this. Okay. Now when let's say after all the arguments we find out that this is the line of best fit, then it's a line. The line of best fit. You can find out the slope of this, you can say, okay, fine. This speed is increasing when you go from 9 a.m. till 12 a.m. This is the congestion time and the speed is less, but the slope is increasing, meaning when the time passes, the traffic speed increases. That is against the slope of that line, the line of best fit. But what is the takeaway from this? I gave the example of AI because Arab keeps talking about AI, and there is no harm in doing that. AI uses this extensively. This is used in scenarios where you have machines and robots recording data, lot of volume of data, and then plotting that in some mathematical algorithms to derive the interpretation from it. So this is used extensively in big data, in all those Facebook or YouTube related things. They use different machines and tools to capture the data, plot a scatter plot, derive the line of best fit, find out the slope, derive the trend out of it, and then help you conclude something based on how it is captured. Okay? Yep. Imagine a 2-year toddler playing on YouTube versus somebody like me doing something on YouTube versus my parents doing something on YouTube. Right? Everybody has different behavior, different choice, different selection of videos they watch. Scatter plot becomes a handy tool for dealing with such a scenario. Okay? So we talked about bar chart, when do we use it? We talked about histogram, when do we use it? We talked about pie chart, when do we use it? We talked about dot plots. Then we talked about scatter plots. Any questions here so far? No questions? Yes questions? Many questions? Yes.
Which out of all of these like graphs are used most often? Like except like bar graph?
It's bar graph and pie chart. These two are very commonly used graphs. But line graph is another one which comes along with bar graph. When you guys deal with Excel and those things with time, you'll see that Excel gives you a lot of ability to capture data and then create graphs out of it. So you'll see that bar graph and line graph are always together as a add-on. You can choose whether you want line graph along with bar graph or not. Pie chart is another one where you are talking about distribution, which you'll use very commonly. Scatter plot is a conceptual thing that we learned. You will get it for your exams and all. How much you will use depends on how much you are dealing with AI, ML, data science, or AI related stuffs when you guys grow up. So it depends. Then we talked about line graph also, which is used for deriving a trend. So let me call out the names one by one. Vasundhara, Arihan, no questions, beta? All good? Tansi, no questions. Tikshita, Sandrin, Celine, no questions. Sami? Suhina?
So I have no questions.
No questions. Okay. Then who? Advi, Kalav, no questions. What does this mean? Arav, tell me, what does this mean? Okay, so I'm assuming there is no questions. If there is no question, why you guys are wasting time with me? Go home, take rest, have fun. Talk to you guys next Saturday. Alright? Don't waste your time with me anymore for today. Bye bye, take care, bye bye. Bye bye. Bye bye, bye bye, bye bye.